Alright, so let's suppose that we actually want to multiply a couple of matrices. And by the way, perhaps I should just add at this point that there's no such thing as matrix division. Division doesn't exist when we're dealing with matrices, so just be aware of that. No such operation as division. Okay, suppose we wanted to multiply two matrices. In order to find any particular entry, A sub ij, that is to say that in order to find an entry that is in the I row and the j column, well then we must multiply the ith row of the first matrix by the jth column of the second matrix. Now this sounds confusing until you actually see it done, and then I think you'll catch on. So we'll just do a couple of examples. So the first one says, multiply these matrices if possible. So first we'll have to check their dimensions are compatible. This one's got 3 rows and 2 columns, so it's a 3 by 2 matrix. And this one has got 2 rows and 3 columns, a 2 by 3. We can see that the inner dimensions are equal, so yes, it is possible to multiply them. And we will use the outer dimensions 3 by 3, so we know that our answer matrix is going to be a 3 by 3 matrix. Alright, so let's set up a 3 by 3 matrix. Here's my first row and my first column. So in order to get this entry that is in the first row and the first column, I need to multiply my first row of the first matrix by the first column of the second matrix. So this is entry A sub 1, 1, right? Row 1, column 1, A1, 1. I need to then multiply row 1 by column 1. Now how do I multiply a row by a column? We're going to take the first entries, 1 times 2, and we'll add them to the second pair of entries, 0 times 5. Let's move on now and do the first row times the second column. So we've got 1 times 1. So you'll notice I'm putting it into the spot, the first row and the second column. So I've got 1 times 1 plus 0 times 0. And now let's do the first row, third column, in order to get the entry that belongs in the first row, third column. So we've got first row, 1 times 3, plus 0 times negative 1. And this is where my 3 by 3 matrix will end. Let's now move on to the second row. In order to get the second row first column entry, 2a sub 2, 1, we need to multiply the second row by the first column. So negative 2 times 2, negative 1 times 5. Now we're looking for the entry in the second row, second column. So we'll multiply the second row by the second column. Negative 2 plus 0. And lastly, we're looking for the second row, third column. That's entry A sub 2, 3. So we need the second row times the third column. Row 2 times column 3. Negative 2 times 3. Negative 1 times negative 1. And now we'll work on row 3. I'll do this one a little bit quicker. Row 3, column 1. So row 3, column 1. 3 times 2, negative 4 times 5. You'll notice I'm always adding these products together. Row 3, column 2. Row 3, column 2. 3 times 1, negative 4 times 0. Row 3, column 3. Row 3, column 3. 3 times 3, negative 4 times negative 1. And now we'll simplify this matrix, giving us, let's see, 2 plus 0, 1, 2, negative 9, negative 2, negative 5, negative 14, 3, and 13. And that is how to multiply matrices together. Okay? Let's have a look at another example. In this situation, we've got a matrix with 3 rows and 2 columns. It's a 3 by 2. And the second matrix has also got 3 rows and 2 columns. It's also a 3 by 2. What can you conclude? Because the inner dimensions are not equal, we can say that it is impossible. Okay, and if we want to be a little bit more specific to explain why, we could say since the dimensions are incompatible. So just to finish off then, let's just review this concept of matrix multiplication and think about these dimensions again. Suppose that matrix A has got dimensions m by n, and matrix B has got dimensions p by q. It is only possible to multiply them, so the product AB exists only if, well, the inner dimensions are equal. So n has to equal p. And the dimensions that you get off this product matrix will be your outer numbers, m by q. I just kind of want to return to the problems that we were looking at a moment ago and show you why this is. Imagine that your inner dimensions were not equal, like in this problem. So we're going to take our first row times our first column. 1 times 4 plus 0 times negative 1 plus what times 0? Like, there's not the same number of entries in the first row as there are in the first column anymore. But over here, because the inner dimensions were equal, for any row and any column, we always had the same number of entries in the row as in the column of the second matrix. And that ensured that we would have a perfect pairing of numbers to multiply up before adding those products together. So I hope that's kind of another way that you can see why the inner dimensions must be equal for the matrix multiplication to even be possible in the first place. Now, I just want to show you how we can multiply matrices on a calculator so you can get some calculator skills. There's a matrix feature on your calculator that you'll find on the 4th button down, right above. So we'll have to press second x negative 1 to access it. Let's enter in this matrix right here. This is a 3 by 2 matrix. So I'm going to edit a matrix I will name A. Enter, and we know it has 3 rows and 2 columns. And you can see the structure of our matrix has been prepared. Now our entries are respectively 1, 0, negative 2, negative 1, 3, negative 4. And make sure you press enter after you've put in the last entry, so that it has been actually recorded. Now our matrix has been entered. Let's quit. Quit is up here above mode, so second mode to quit. We go back to the regular screen. I now want to create a new matrix. Let's create this second one, this 2 by 3 matrix, and we can call it matrix B. So we'll go into the matrix menu again, and we need to edit a matrix. Let's go down to make sure B has been highlighted. Let's edit a new matrix called matrix B, which has got 2 rows and 3 columns. And you can see the structure of matrix B has been prepared for us. Let's put in the entries 2, 1, 3, 5, 0, negative 1. Make sure you press enter after the final entry as well, so it has been actually recorded. Let's quit. Now I want to take that matrix A I created, this one here, this was my matrix A, and I want to multiply it by our matrix B. So this is, in other words, I need to find the matrix who I named A. So let's call up the matrix. The one that is name is A. And hit enter, because A is currently highlighted, so there we go. So anytime you actually want the matrix to appear in your calculation screen to be able to say multiply them or add them or whatever, this is how you do it. Okay, you go to matrix name, and we want to multiply this by the matrix named B. And there we go, there's matrix A times matrix B. Let's hit enter and see what it gives us. Beautiful, the exact same answer that we found by hand. Uh-oh, did I make a mistake? We didn't get the same thing in that top right entry. What happened? Oh, I'm so dumb. You guys must have been listening to me for the last 5 minutes wanting to correct me. Clearly, 0 times -1 right here. So remember I did first row times third column? I have 1 times 3 is correct, but 0 times -1 is 0, isn't it? And I'm kind of glad that this happened, because I have to warn you, it's really common to make this kind of silly mistake. Because you're doing so many simple operations again and again and again, it can happen. And so, we just have to be very careful, and if there's time at the end of a quiz or the end of a test, we would possibly do our matrix multiplications again to make sure we didn't do anything silly like I did. And so, yeah, my fault about that. This shouldn't be a 2, it should be a 3. And there we go. Now the answer that I got on the calculator corresponds to the answer that I got manually.